from this group, one person from this group, and then if I match their properties, then I should find that they are very different from each other, right? So that is the whole aim of the clustering. So it deals with finding a structure in a collection of unlabeled data. So here we are saying the data which we have here is the unlabeled data, and that is what we need to, find out, right? The structure, unlabeled data is there. So I have been taking already this example in earlier lecture also, whenever I had to make the differentiation between the supervised and unsupervised learning. So we will be taking same example quickly so that the people who have joined first time, they can know also. So supervised learning is equivalent to this example. Let's say if you go back to your childhood and first time you see one fruit, and then you ask your father, what is this fruit? And your father says to you that this is apple, let's say. And similarly you ask for other fruits, then you told, okay, this is banana and this is orange, right? So this is a supervised learning because your father, mother are supervising you, right? So now if you, let's say sometime you are alone at your house and you got the call from your parents. Your parents are saying that we have sent a basket of fruits, kindly make sure that you are segregating all those fruits into different baskets. So you become very much excited, right? Because you are going to have fruits on your own first time, let's say, and when they come at your house, then you segregate them properly into different basket, because you know already that which fruit is which one, right? So this becomes a supervised learning technique. But what is clustering or unsupervised learning? Let's say nobody told you which fruit is which one. You go back to your childhood, you never saw a fruit, let's say, till now, and then you got a call from your parents, you are alone at your home, that we are sending a fruit basket, kindly segregate the fruits, different fruits kindly put into the different basket. But now you become worried because you never saw earlier fruits, so you do not know which fruit is which one, let's say. And then the basket reached to your house, you are opening the basket, having little bit worry in your mind, how I will do this task given by my parents. But as you open the basket cover, then you look into the properties, and then you are finding, oh, these items look similar, so it means they should belong to same group only. So because of this reason, because of the properties which you are looking into, even though you do not know what is banana, what is orange, what is apple, but by looking into their properties, you were able to form the groups properly, right? So this is what we say as the clustering technique, right? Nobody told you earlier, it is completely unlabeled data, which fruit is which one, but still you are able to segregate them, even though still you might not know what is apple, what is banana, or what is mango, but still you are able to segregate them into the groups. So some of the techniques, clustering techniques, are K-means clustering, which we will study. Then we have fuzzy C-means clustering also, and hierarchical clustering techniques also are available. So let's see where it can be used. It is used in marketing for discovering distinct groups in customer databases, such as customer who make a lot of long distance calls. So let's say you got your customer, right? So you might have business of anything, might be a fruit, might be anything, right? And where you have the properties of the customer, right? And now marketing for discovering distinct groups in customer data. Just a second, my YouTube. I just started the YouTube as well, so that I can see the comments or question asked by the people. Okay, so yeah, what we were discussing about the clustering use cases, right? So you might want to segregate the customer so that you can think of providing or targeting the different groups for a different purpose, right? Or you can know exactly for your product which group you should focus on, right? So you have the properties of the customer currently, and just on those properties you are grouping them, and later on you study each and every group, and then you think which group you should target for marketing of your product, right? So because of this you can reduce a lot of work, right? Rather than randomly doing marketing or marketing to all, you can directly focus on your own customers. Similarly, in insurance, you see that same insurance cover is not given to all kind of people, right? So for different kind of profiles, there are different insurance policies, right? For farmers, insurance policies would be different. For businessman, insurance policy would be different. And for job person, private job person, government job person, they will have different insurance policies, right? So how they are looking, again, they do the grouping of all the people. They get all the people and then they group according to their properties, and then they decide that to which group what kind of policy they should bring in, right? So this way you can use the clustering technique in a lot of places as well. So let's talk about the types of clustering techniques which we have. We have three kinds of clustering. One is exclusive clustering, another is overlapping clustering, and next is hierarchical clustering. So what is exclusive clustering? Exclusive clustering is a technique in which one item just belongs to one cluster, right? So here we can see this item belong to this cluster, these item belong to this cluster, and these blue item belong to this cluster. It is not happening that one item, let's say this item, is not belonging to more than one cluster, right? So each and every item is belonging just to one cluster, right? So this is what we call as a exclusive clustering, and K-means is one of the such technique which works as a exclusive clustering technique, or which is used to create the exclusive clusters, right? But sometime what happen, there might be overlapping cluster might also be possible. That it is okay if one items may belong, or one data point may belong to more than one cluster, right? So such kind of technique are known as the overlapping clustering, and we may say that one particular item will have their belongingness to the cluster, and their belongingness might be more to one cluster, less to other cluster, and we say this belongingness as degree of association as well with each cluster, right? And the technique which we use here is like fuzzy C. Fuzzy C mean clustering technique is being used for doing the overlapping clustering, right? So here this is little wrong. This is overlapping clustering should be here. Okay, so let's take an example. Let's say if I am clustering the news article, let's say, right? So on the basis for which particular purpose is. So when I doing the clustering, so by default it happens one cluster become for the politics news, one cluster become for the business news, one cluster become for the sports news, one cluster become for the entertainment news, right? So these are four type of cluster, let's say, created. But let's say there is a one news which belong to IPL, right? And IPL news is actually a sports news as well as business news. It might be, right? So it might be talking about the both things together in a news where it is talking about the sports, that is cricket, and with the business, right? How the business is being done with the cricket in IPL, right? So if this is what they are talking, it means it is not going to belong to one cluster, but it is going to belong to two cluster. One would be our business cluster, and another would be our uh, sports cluster, right? So this is what our overlapping clustering is. Sometimes we need hierarchical clustering technique. So what is hierarchical clustering technique? Where we have the parent-child relationship. So we do what thing in this case is we initially make a small cluster, right? So this is one small cluster, one small cluster. These are, let's say, some small cluster are there. Then we merge some of these cluster together to form a bigger cluster, right? So these two would be merged together, these two would be merged together. Then further we can merge them together into the bigger cluster as well. So there becomes a hierarchy of cluster, right? So this is what is known as a hierarchical clustering. You can think, let's say, I want to do the clustering of the land. Let's say land is given, right? Let's say nobody initially told there is a no division is there, let's say, of India. It's only a one country, India. But now I decided, okay, I'm going to divide it into different states or cities and so on, right? So by looking into the property, first of all, I start dividing them into the cities, right? Then I thought, okay, there should be some hierarchy. Then I start merging some cities together to form the cluster, right? So you can see hierarchy of the groups uh, cluster start becoming, right? So this is what we known as the hierarchical clustering. And let's talk about, and which is the topic of today, that is K-means clustering. So K-means clustering is one of the simplest algorithm technique which uses unsupervised learning method to solve the clustering issues. So we have the clustering issues which we need to solve using the K-means clustering, and you are going to find it is one of the very easiest algorithm in the clustering, right? It's pretty easy to understand as well as easy to implement as well, even though we will use the library, but still it is not much difficult to write your own functions to do the K-means clustering yourself. So how does it work it actually? It works it by dividing entire data set into K cluster. So why we are calling it K means clustering? Here we have the two terms K and means. So we will see what means meaning is. And K is representing here number of cluster. So we decided when I say okay, the it is K value is 5. So it means I need to divide my data set into 5 cluster, or I need to form the 5 groups, right? So here you can see this is a total population which I am dividing into 4 groups. It means K value in this case is 4. So it will require these two input. One would be your K, that is number of cluster, and second would be your training set. Or training set is nothing but the all the data points we have. So all the data points x1 till xm. Let's say we have m data points, so we are saying them x1 to xm. So these two things we need to give as input. How many number of cluster I want to form, and the training set here, right? Data set which I want to divide into the cluster. So here they are showing one of the example is of the Google News. So what you might be doing here, let's say you read some news on the Google, right? And when you are reading some news, it start giving recommendation to you for some other news as well. So how it is happening actually? By using the clustering only. So it basically cluster all the articles into some groups, right? So this is one group, second group, third group. This way it cluster all the articles. Now let's say you are reading one particular article from some cluster, right? You randomly choose any article, right? And let's say it is related to Trump Modi, right? And let's say it is related to Trump, right? Where or it is related to president. It is talking about the president or prime minister, let's say, right? So what it start finding is which other news article comes under the same group. So it finds out, so because already it has created the group, because similar kind of news it put into the same group. So once you start reading the one news, then it sees to which particular group this particular news belong to, and then it gives you some recommendation of other news which belongs to same group exactly, right? So this is how it do the recommendations. Okay, or let's say the plot of students in an area is given. So let's say it has been given how these students are formed. Let's say this is a 2D figure has been given to you, and each of these circular points are nothing but a student. So these are representing the student. And let's say you decided that I want to open 3 schools. So where shall I open it, right? So I should open in such a way that so that I can get the maximum student in my schools, right? It should not happen all the 3 schools get at one place, or maybe one is at this place, right? In such a places where nobody comes. One is here, and let's say one is here, right? So that it become far away from most of the people. No. So we need to find out how we cluster them these students so that we can decide, okay, this particular student can go into this particular school and where this school need to be exactly, right? So for that we can do our clustering technique, and when we do the clustering technique, then we found, let's say this become one group of student, this become another group of student, these would be coming also in some group, and this become another group of student. Then you look into the center of each of these group, and at the center of each of these group you can open your school, right? And that is how you can decide where you can locate your school, or where you can open your school, so that it can benefit maximum students as well as it can benefits you in terms of monetary gains if you are going to take this fees from the students, right? So but the question is, but how did he do that? So how it can be done? So we will see this thing. It is we are going to do on the basis of K-means algorithm, right? So first target which we have is to choose the number of cluster, right? So how to choose the number of cluster, I will come at the end about it actually. First I will show you other steps. If let's say if you know already how many clusters you are going to form, then how it is going to work, right? First I will show you, and at the end, after showing all these things, I will come to this particular topic again, that is how to choose the number of cluster. So first of all, let's say we choose some cluster, right? So let's say we choose the value of k, that is number of cluster I want into my data set, is 2. Let's say k value is 2, right? So value of k, that is number of cluster that can be determined by the elbow method, which was given earlier. But let's say we reach to this conclusion that 2 cluster we need to form, and this is our data set. All these circular points are given. These are our data set, let's say, right? And let's say what I'm going to do as the first step is the initialization. So what is the initialization? If I am choosing, if the value of k is 2, means if I have to form 2 cluster, then first thing I will do is to take 2 random points, right? Take 2 random places in my coordinate system, which would be known as my cluster center, for example, right? So here they have taken this particular place or this particular thing as the centroid 1, and this is they have taken as the second point. So they are saying these two would be working as a centroid of the cluster, right, or the center of the cluster. So how did we reach to this conclusion? By taking randomly completely, right? So initially we are taking randomly even though, but we will see how nicely it is going to get the shape. So when we take this these 2 points randomly, so what we are going to do now, for each and every data point, we will calculate it distance from both the points, right? So for this data point, let's say I calculate its distance from this centroid and as well as from this particular, right? And I will see to which it is more closer, right? So definitely this distance is less compared to this distance, right? So which I will choose here. I will say, okay, this data point is going to belong to this center. Similarly, I will see this data point is going to belong to this center, and this data point belong to which center? This center, because this would be less distance compared to this distance, right? So we will allocate the cluster to each of these data point on the basis of their distance from the randomly chosen centroid, right? And so here we can see when we find out distances, then we found that this become the cluster, that all these orange points are basically more closer to this orange. So that is why we are saying they belong to one cluster and these belong to another cluster, right? Because of their distances. Okay, once we get this thing, now we will calculate their new centroid, right? So earlier we got the centroid, now we are going to do the new centroid. So how do we do the calculation of new centroid? Basically, we will take this these data points which belong to same cluster, like these belong to same cluster, and these data point they belong to same cluster, right? So we will take this data point and we will choose their center. So for its center would be coming somewhere here, for these data point center would be coming somewhere here, right? So these would be our new centroid, right? So that is just the means of all these data points. So this particular center is nothing but mean of the orange pointed points. This is the mean of all these blue points. So this way we calculate the new centers, right? So here you can see these two has been calculated as the new centroid. And again, so once we get these as a centroid, now what we are going to do, we are going to do again the same thing. That is, now we will find out again the distances. So what would start happening? Now this data point is more closer to this compared to this new centroid. So its color would be changed to orange, right? So we will reassign all the data points to the new centroid, and then we will see to which cluster it belongs, right? So we do this reassignment, then we find that this side data point will belong to this and this side belong to this particular centroid, right? So this way we are going to get our new cluster now, right? So it would be saying this one, it would be saying this one, and then when you calculate for orange new centroid, it would be this one, and for blue when you calculate the centroid, it would be this one, right? Now after that, again you will see for each of these data point which are the nearest one. But now when you see, you will find out it is not going to change the centroid, right? The same centroid you will find again. So now you will see this data point is closer to this only compared to this one, right? So all these data points again belong to same centroid. So when there is a no movement of the data points from one centroid to another cluster, or when there is no movement in the centroid of the cluster, it means we have reached to the conclusion where this is our final cluster, right? So this is what we are going to have at the convergence, where we say now no more changes happening. It means our clustering technique has converged, right? So this is how do we do this thing, right? So this is how K-means algorithm works. Okay, so we will talk about the demo, but one thing is left still, which we were discussing initially, that is how to choose number of clusters, right? So choosing number of cluster, we have one technique, we call it as a elbow method. And for elbow method, first of all, we need to calculate the square distances, right? So we call it as a WSS. So how it is being calculated? Let's see how it is being calculated. And whenever you have questions, you can just post your questions as well. So let's see how it is being calculated. So this is so we will take the k value. We will take first k value is equal to 1. We will think what if k value is equal to 1, right? That is a number of cluster we are considering is only 1, and then we will see what is the value of a WSS, or we call it as a within sum of squares. You will see what is it and how is it being calculated, right? So we call it as a within sum of squares, and we calculate it. Then let's say for k is equal to 1, this is the value we are getting. Then for k is equal to 2, we will do again calculations, right? For k is equal to 2, we will do again, and let's say for k is equal to 2 something, here it will be coming. Then for k is equal to 3, we do this calculation, it will be coming here. K is equal to 4, we do, and for different k values, we basically calculate this WSS, right? Right. So Darshan, I will take your question at the end, right? So your question, I read it, understood it, and at the end, once we finish the K-means, then I will take your question. And if I forgot to take your question, you just remind me again, right? Okay. So what we were discussing here? Yeah, we were discussing about that we will find out the WSS. How to calculate, we will see. Then after that, after finding these WSS, we will do this. We will draw this graph, right? So we'll draw that for 1, for 2, for 3, and then we'll join all these points, and the graph will be coming something like this way, right? So this way we got our we got our here WSS, right? So once we calculate this WSS, then we look after doing this drawing of this graph, we will see till which point the reduction in WSS is happening, right? So we see from here to here, right? Reduction in WSS is happening so fastly, right? But after that, the reduction which is happening is in WSS is negligible compared to how much reduction it was happening earlier, right? So it means this is the right point, right? So it means this is the right number of cluster, right? So 3 is the value of, in this case, in according to this graph, k is equal to 3 is a good cluster here, right? So that is our how do we calculate the how many k value we should choose, right? But now there might be there is another question now. How does this WSS is being calculated? So this WSS is being calculated according to this formula, right? So first of all, so let me just, rather than taking you to the formula, let me open the notebook and notepad, and here we can have this case. Let's say this is my data set, right? Let's say this is my data set, right? Let's say this is my data set here we have, right? So if I ask you how many clusters are there by looking into this, so you guys can tell pretty easily. The k value should be 3 in this case actually, right? We can see there are 3 clusters only here, right? So but let's say, yeah, we initially think that when k is equal to 3, so we will do what, we will form the cluster, and when we apply our k-means algorithm to this, then one cluster would be this one, another cluster would be this one, and another cluster would be this one, right? So these 3 would be our clusters. Okay, And then what we will do for these three clusters, we will calculate their centers, right? So let's say the center which we are getting here for this cluster, this is the center. For this cluster, center would be coming here. For this cluster, center would be coming here. Then for each of the data point within the cluster, I will calculate the distance. So I will calculate this distance, this distance, this distance, this distance, this distance, this distance, right? And I will add all of these distance. So for this particular cluster, when I add these 5 distances, let's say it is coming as a, right? So let's say it comes as a. When I do the calculation for this also, I will do the same thing. From its center, its data point distances, I will calculate, right? So from its center, from all these data points to its center, I will calculate the distance. Let's say this is coming as a b. Similarly, here we will do the same thing, and let's say here in this case it is coming as a c. So what would be the WSS value for this case? So WSS, let's say I am saying WSS 3 is equal to what? A plus B plus C, right? It would be A plus B plus C, right? So this is the case when K is equal to 3, right? Let's say if I take K is equal to 2, right? Then so I will be taking K is equal to 2. In this case, let's say the cluster which is being formed is such a way that these two become a one cluster, right? And this become a one cluster, right? So let's say when I take K is equal to 2 and apply my K-means algorithm, let's say these two it made as belonging to one cluster, and this particular they made it belonging to one cluster. Now what you will do here, you will find out center for them. So let's say here you are getting center for this cluster, and for this the center would be same only. So when for this cluster you get the distances would be exactly same, right? So for this case it would be C again, right? When you take all the distances, add them together for this cluster, it would be C. But for this cluster, you will take all the data points, find their distances from this center, right? So here the center is different, right? And when you do this thing, this is the way center would be coming, right? And definitely you can see here this. So let's say this particular value would be D here, right? So when this is a D, so WSS for when I'm considering two cluster becomes D plus C, right? Where D is the distances from the center of this cluster to all its data points, right? So this is how do we calculate the WSS, right? Okay, so Lambert is saying, hello, the presentation is not moving, it's stopped. May you please help me to have the presentation while you are going through the presentation. Thanks. So is it moving for other people? I can see it is moving for other people actually, right? I can see on the YouTube also it is working perfectly. So you need to re-log in, maybe there is some connection problem you have. Okay, so this way you will calculate the WSS2, right? And if you really look into this, then you will find D is always greater than A plus B, right? D distance, if you see, is going to be greater than A plus B. So this way you can calculate for different value of K WSS, and then you draw this particular graph, right? Which we can see here, right? So this particular algo method we say, and then you see when the WSS is reducing, at whichever point its reduction start becoming very less, then you say this is the point where it is. This is the point correct value of K for me. And you can look also here one more thing. We call it as a elbow method. Why we are calling it as a elbow method? Because you can think this is like a hand, and this is nothing but the elbow only, right? So this is wherever it is becoming a elbow for the graph, then we say this is the place where which will be chosen as a K value. Okay, so I hope so it is clear to all of you guys, right? So let's go ahead. Okay, we discussed all these things. Okay, here, so before going to demo, let me okay, so let me keep it very simple here, and let's go to the demo, right? So we are going to have the demo now. So we open a new notebook so that we can see the demo. Okay, so we will do first thing. First of all, we will generate some random data points, right? And then we will cluster them. And how we are going to generate these? Through some random centers itself, right? So let's do this thing. So first of all, we will generate ourselves some data points, right? So how do we generate these data points? So from sklearn, we have one library. We have module that is data sets. So this particular module help us in creating our data points randomly. So import make blobs, right? So this is a particular function which is going to help us in creating the data points, right? So we, let's say data points which I am creating here, and then I call this function make blobs. Here I tell first of all how many data points I want to create. Let's say I am saying number of data points which I want to create is 200, right? And after that I tell how many features, means how many features should be there in my data points, right? Or columns or variables should be there in my data points. So for that we have number of features, and features we say, so let's keep it 2 so that we can easily draw it and visualize it very easily onto our screen, because it would be 2-dimension figure only in this case. And then we say, so let's have some more data point here. So let's say 250 data points we are having here. And after that, let's say centers. So we are saying center means, so how it generates the data point, right? So that is what I write as a center. So I will say 5 center, suppose. So what it is going to do is, first of all, randomly it will choose some 5 center, like one is here, let's say one is here, another is here, another is here, let's say, and another is here, right? So these 5 center, first of all, it will create randomly, and then it will create 50 points, like 50 points which are near to the center, right? 50 points it will create around this particular center, 50 points it will create around this particular center, and 50 it will create around this particular center, and 50 it will create around this particular center, right? So here we are say telling it around how many center it should create the data points so that it becomes 250, right? So we are saying 5 center, so that 50 around each, right? And we tell also that when it creating a randomly these data points around each of these center, then around these center how much standard deviation, within how much standard deviation it should create these data points. So let's say cluster standard deviation is 1, so that it takes standard deviation, or you can think as a diameter of your cluster, and around within which it would be creating these data points randomly, right? So this way we do it, right? And okay, so let's have the random state as well, some. And random state means it is a seed value for creating these values, right? So if you also, because I'm creating these data point randomly, if I create here and you create there, we might get different result. But if you want the same result which I'm going to do, then you need to make sure you are using the random state is same which I'm using here, right? So it is giving here and sample, it should be number of samples. Okay, now this is our data point, right? So if I want to look exactly what my data points are, I write data 0, right? So first of all, I write here, sorry, data points 0, right? So these are my data points. So P Rajavamsi is saying whether n sample should be exactly divisible by center, nothing like that. You can have more, less. So accordingly, it will just have then some of the cluster point will have little bit more point compared to other. That's all, right? So there is no as such hard and fast rule. Okay, now you can see these are the data point it has created. So this is the first data point, this is the second data point, this is the third data point, this is the fourth data point, fifth data point, and so on. So this way it has created 50 data points, right? So we can say 50 data point. So data point is what basically it is a tuple in which at the 0th position I have these data points, right? But if I see data point 1, if I write data points 1, then basically it is telling that to which center it created around, right? So basically it takes 5 center to 1 0 1 2 3 4, right? So it is saying that basically this first data point belongs to the second center. This next data point belong to first center. Next data point belong to first center. Next data point belong to fourth center. Next data point belong to third center. So for each of them, it is telling that around which particular center this particular data point has been created, so that you know also that to which in reality to which group they belongs to. But in the real world, you might not be knowing exactly that to which particular to which particular group they belongs, right? So this might not be available in reality, but we are keeping it so that we can see exactly how the results are coming. So if we want to draw, we can visualize our these data points as well. So for that, we will import matplotlib.py plot as plt, and then we will make here plt.plot, and within this, sorry, we want it to be scatter plot. So plt.scatter, we write here data points, and we will have, so we x-axis is this first column, y-axis is this next column, right? So if I write data point 0, I will get all the data points, and within the scatter x-axis, I need to tell what is my x-axis is this first column. So I say that within these data points, all rows I want to take of the 0th column, right? So this particular column would be 0th, and using this column I am saying all the rows, right? So that is my x-axis value, and similarly I tell the y-axis value for these same data points, but this all the rows it should keep, but column should be 1, right? So if I draw it simply plt.scatter this way, so these are the data points which it has created, right? So these are all the data points it has created, right, automatically here. And if we want to see also that which data point belongs to which cluster according to it, we can add one more value, that is c is equal to where we have their real value, that is data 1, sorry, data points 1, right? So you can see all the same color is being shown as that to which particular group they in reality they belongs to, right? So this particular group, it belongs to this, right? So you can see very compact uh, centers here we have, because here we have take standard deviation value is 1. We will change the standard deviation value as well, and then you will see how it is going to make the impact here. Okay, now let's see the next thing here. After doing this thing is we are going to apply our k-means algorithm, and then we will see what result it is giving us, right? We will forget about this data point 1, and we will apply our algorithm, and we will see what result it give us. So for that, we need to import from sklearn.cluster. We are going to import k-means, right? So we imported it, and after that we will create its object, right? So we say k-mean cluster model is equal to k-means, right? And here we need to tell number of cluster we want to have into our data set, right? So here number of cluster we write is, we know already here 5, so let's keep it 5 currently here as such, right? So after doing this, we can do the fitting dot fit, and we pass our data point without their labels we pass it, and after that it has created the model. So if we want to look what are the centers it has calculated, so we can use cluster centers. So these are the 5 centers for each of these clusters. So it has created the cluster, we will see the result of the cluster as well, but these are the center. This is the first center, this is the next center, this is the next center, and so on. This way all the centers has been calculated, right? Similarly, if you want to look their labels, what is the label it has provided or which has been belonged to which group, So it is saying the first data point belongs to second group, next data point belongs to zeroth group, next belongs to zeroth group, next belongs to fourth group, and so on, right? And we can draw it also. So let's say let's draw both of them together so that we can see both of them on the same page itself, right? So we write fig ax1, ax2, then we write psd.subplots, and within this, let's say 1 comma 2, right? That is, we are saying within one row both the figures we want to draw, right? And ax1 dot set title, we are setting the title, let's say this is original data, right? And then we say ax1 dot a scatter plot only, and within this scatter plot we can pass over the same argument which we passed here, right? So that we can draw it here, and let's copy paste these two commands, and now we will do it. We will draw it for k-means. So let's make it ax2, make it ax2 here in place of original, and let's say k-means output, right? And here in place of data, because we do not want to use the label which is really provided here, we want to see what has been done by our system. So we write k-means cluster model dot labels. Now when we execute it, it is creating this. So you can see this is original cluster. This is the result of the original cluster. This is the result of the k-means output, right? So in reality, this was a cluster has been made as a one cluster. The colors has been changed. Just that's the difference, right? So color has been changed. It does not know what the same cluster is being shown here, right? It just formed the group. So it is showing that green color one cluster. So this is a one cluster, and here also we can see the same data point belong to same cluster. This belong to same cluster. All these belong to same cluster. So it gives exactly the same result as we have here, right? So seems very good here. But now what I'm going to do, because here it's very easy boundaries to be make differences among them. But let's say I'm going to increase the standard deviation between the data point, and then we will see exactly what result we are getting if we have little bad way our these data distribution. So for that, what I'm going to do, I'm going to increase the standard deviation to 2. So when I do this thing, right, and when I do this thing, I execute this plot, then you can see now these clusters are little different, right? You can see data points are merging also here, like this. There is no clear cut boundaries as such, right? So you can see these two are getting intermerged together. There some points also getting intermerged here, right? So these are the cluster here. I just increased the standard deviation, because of which, rather than giving compact groups, it start spreading the data points around the cluster center, right? So this is a new one. Let's say if I apply onto this, right? If I apply onto this, this thing, then will get this different center, label different. And if I see this output now, so this is our output, right? So here you can see the output might be little different. So you can see in between these data, 2 points are coming, right? These belong to this particular cluster, but here you can see these two data points here is they are making it belonging to this cluster itself, right? So while here it was belonging to this particular cluster, while here they have made it belong to this particular cluster, right? So you can see little bit changes in the result we might be getting. Here you can see these data point, these two belong to different and these belong to different, but here if you see within our result, then you can see it start making it belonging to the same result, right? And it makes sense also. Otherwise we will not have in reality clear boundary, right? The data points has been generated randomly, so they might have crossed their boundaries, but when we apply our technique, K-means algorithm, it will have their clear cut boundaries, right? There is no intermixing of the boundaries at all, right? So this way we will have this result, right? So I hope so this is very much clear to all of you guys here. And let me know if you guys have some questions. Okay, so there was one question was being asked by Darshan, that methods apart from K-means. So if you are asking the types of clustering, different clustering technique, we have seen few different clustering technique on already during this presentation. First of all, right, like we discussed about exclusive clustering, which is our K-means clustering. Then we discussed about the overlapping clustering, which is our fuzzy or C-means clusterings are there. Then we have hierarchical clustering also, and we discussed about this also. So I hope so you have seen this slide, but if you have joined later, then you can go through do this thing, right? And another thing is there are many other clustering techniques are there. It's not like it is just finished here. We have one of the very good technique is DB scan technique is also there, right? And that is a density based clustering technique, right? So on the based of the density it will the cluster. So this way we have many other models are there. Okay, so Hari is saying, how does the model select the centroid? Randomly, initially, are there any boundaries? So actually, there is a one thing I didn't tell or not included actually in this PPT because we want to keep it so much simple. But if you have bring this question, then let me tell you that yeah, we are selecting the initial centroid completely randomly, right? And after that it is being changed, right? Then the things happen there further, means according to the which data point belong to which centroid, the things start happening. But your question might be also, what if I execute my same code two times and if I get two random two type different centroid in both the cases, whether the end result would be same or it would be different. So let me tell you, it might be different. It may be same in many cases, but in some cases it might be different as well. And it happens many times that the way you are choosing the boundary, right? The way you are choosing the boundary is basically the way you are choosing the boundary decides sorry, not boundary, the way you are choosing the random initial data points may also impact how good result you will get, right? So as such, randomly, even though we are saying, but there has been few algorithms also has been devised to select the initial random points. So one of such algorithm, let me tell you, uh, one of such algorithm do it in such a way. So first step is, let's say if I want to, let's say this is a data point I have, let me draw some data point. Let's say this is, I have some data points here, I have these are the data point, right? Then I have here some data point, right? And then here I have some data point. Right? So if I say k is equal to 3, then how you will form the cluster? Definitely this would be one cluster, this you will take as another cluster, and this you will take as another cluster, right? That is how if I take the k is equal to 3, right? So let me talk about, there are some other question have been asked. Let me just first take this question and then we will discuss other question as well. Okay, so k is equal to 3. If that is the case, then the correct cluster with our eyes we can see these should be cluster. But it is completely going to depend on how I am choosing my initial random data points, right? So let's say initial random data points which I choose. So I am saying, let's say k is equal to 3 only, right? And when I choose k is equal to 3, the one random point I choose here, let's say, and one random point I choose here, let's say, and the one random point here I choose, right? So if I have chosen these random points, so then I will start allocating data points to these three. And what would happen? I might get some such kind of result that it become one cluster, these become another cluster, and this become another cluster, right? So this is the result I will get, right? If these red random points, if I have taken initially, right? and in reality the data point should be different, right? So here in this case, what you can see now if I calculate their new center, would be coming for this here, for this here, and for this case this would be the new centroid. Then if I do, still this would be the cluster, this would be another cluster, these would be another cluster, right? And we can see at the end we fall with the wrong result, and this is not the correct result at all, right? So it matters what you are going to choose as your initial random point, right? So how we can choose in this case? So what is one of the good algorithm for choosing initial random point? Let me draw this figure again. Let's say these were the data point we had, right? So let's say these were the data point which we had, right? So it says you choose first data point completely randomly, right? So let's say when you have to choose first data point randomly, you, let's say, let me change the color. Let's say you choose this data point, right? Now for choosing the second point is not going to be randomly, right? So how you will choose second point? You have to choose which is far different from this particular data point, right? And if we look into this whole data set, then we might see that, let's say this is the farthest data point, so second would be chosen this one. Now when you will choose third one, how you have to choose? You have to choose which is the farthest from these two data point, right? So if you choose this one, it would be very much close to this. If you choose this one, this would be very close to this. So farthest, if you have to choose, maybe this become the farthest data point, right? So these three random data point, if you choose initially, then the cluster which you will get at the end is going to be very good cluster, right? So chances are high that you will get the optimum clusters, right? So this is the way you can choose your cluster, right? So that is how in reality initialization is happening. It's not completely random. Okay. So Anmol is saying, how do we decide the k value? Do we have to run algo method for every time to decide k value? Yes, random way, algo method has to be executed actually for that. And Kumar, so two ways you can run your algo method, or you can visualize your data. If you can visualize your data, you can reach to the conclusion very easily. And if the data is easily visualizable, that is why we keep in this case we keep the data set with two features only, right? Because here we have only two because here we have only two features, so that we can visualize it on our screen, right? And then Kumar Deep saying, how does the standard deviation matter? See, for the K-means algorithm, standard deviation doesn't matter, but we are doing here first creating data points. So when we are creating the data points, then standard deviation matters, right? So it is saying that how much points would be splitted out around the center, right? So like when I had a small standard deviation, right? So when I had very small standard deviation, let's say if I make it zero point 0.5 only, then if I execute it, and if you see this, then you can see how much compact these points are, right? But if I increase these standard deviation value, then you will see they will spill out, right? So if you see here in this case, they are very much spill out, right? The standard deviation is just how you want to create your data points. These creating these data point doesn't has to do anything with the K-means algorithm. I just use it. I just created the data points initially to show you the K-means algorithm by applying onto that. But in the real world, you will get the data set already. You doesn't need to create this data set. You doesn't need to worry about the standard deviation and all those things. You directly need to apply the K-means algorithm on your data points. Anmol is saying, do we get this PPT? No, I think you will not get the PPT. And what you can do, this is always available on YouTube. So you can visit the YouTube, you can get the screenshots from there if you are interested, right? So Hari is saying, should we select the max number of K value while we are following the algo method? Should we select? See, you do this way. You doesn't need to worry about what should be the maximum value of K, right? It is not necessary that you choose, maximum value of K. What you can do is, you first of all all have k value of 2, right? So that you look into the graph, right? So k value, when you add the 2, you will get only that much graph, right? 1 is here and 2 is here, that much only you will get the graph. So you see, okay, still the changes is happening very rapidly. Let me choose another value. Then you choose the k is equal to 3, right? Then you draw the elbow method for that. Then you reach, okay, here till here, still it is getting decrease. Then you choose k is equal to 4, and here till here it reaches, and where it finishes. Now you can see there is a sudden change in the decrease value. So till 4 even it will work here in this case. So gradually you can increase the value of k and keep drawing the elbow method. Anmol is saying, sir, can we write this algo from scratch rather than using scikit-learn? It can be done very easily, but we don't have that much time here to write it. But it is not very difficult or any, any different stuff need to be. You just need to be good with the simple logics. So if you can write the simple logic, then very easily with the few steps which we have here, initialization, cluster assignment, move centroid, you can write this code, right? You just need to write the loops, few loops. But yeah, it will be time taking, not possible to complete it here. So that is why we are not doing this thing. But if you do it and if you stuck somewhere and if you need a help, you can write to the Edureka team. They can make you connect with me with your code. You can send your request to the Edureka team with the code and they will connect it to me. You can say Gaurav Sharma, right? So my name is Gaurav Sharma. You can ask them. I will try to help you with your code. Okay, great. Okay, great. So let's finish today's session here. Thank you very much, guys, for listening with so much patience. And let me show you again. If you have not logged in into, if you have not joined this group yet, kindly join this group www.meetup.com/Edureka. By joining this group, you will be able to access more than 150 webinars every month freely, which is conducted by the Edureka. And these are very knowledgeable webinars you get, right? So from the new technology to the advanced technology stuff, you are able to get the things here. Okay, so Anmol is saying, what is the advantage of this method over other? Simple advantage is it is the easiest algorithm to implementation, easiest to, yeah, understand, as well as from the easy to understand, easy to implement as well, and still generate the good results. We cannot compare actually this with the results because different algorithm generates the result in a different time. So P Rajavamsi is saying, okay, before finishing, I will take one more question. P Rajavamsi is saying, what does random state specify? Random space specify the seed value. You know, whenever any random number you generate, there are different algorithms are there for generating random numbers. So random state is their seed value. If you do not, if you write the random state, same value which I am using here, it means you are going to use the same seed value so that you and me both get the same result for our algorithm. But if I take it away and if I execute it every time I will get different values, right? So if I execute now and if you see now, you can see it is coming first point as -4.5. If I execute again, then you can see this time it is giving me different result, right? So because these are being generated randomly. But if I fix their seed value by using the random state, right, maybe 7, 8, whatever, you can choose anything, then every time I will get the same result and you will also get exactly the same result which I am getting. That's the whole thing what random state is. Okay, thank you, great. So Kumar Dilip is saying, can we get hold if some real-time data by any chance? Okay, you want to say you want to have some data set on which you can apply your algorithm. Is it what you are saying, Kumar Dilip? If yes, okay. So if this is what you are saying, yeah, you can get it. You just write an email to the Edureka team, right? So you might have already somebody might have contacted you. So you can just ask them that I'm looking for data set. We are doing these work, so kindly give me some data set. You can get it. And other than that, you can search on online itself. Very easily, will do. You Google some of the data set. You can which you can use your K-means algorithm or clustering algorithm. You can just write movie data set, right? Or you can write movie data set, or you can write IMDb movie data set. That would be huge real world data, easily available, freely available online, right? And you download the data set and you work around with this, right? So yeah, so maybe a few things you need to remove before you apply your algorithm. Some pre-processing over the data you need to do. Okay. Anmol is saying real-time application of this method. We discussed, Anmol. You saw these things, like we talk about the Google News. We talk about this deciding where I should keep my school open. So it helps also deciding your offices, where you can open your offices and so on. Okay, you joined late, not a problem. You go through the video would be available on YouTube. You can go through again it. Okay, great. Okay, thank you very much, guys. Edureka guest is saying, thanks, Gaurav. This was a very informative session. Thank you very much for appreciating. Anmol saying thanks. You're welcome. And Chris is saying, I love you, Edureka. Great. Jagnesh Jay is saying, how do we know we get good cluster? There is no as such measures are there. There is no measures as such for these things. So you need to there, even though there have been few measures has been decided, and mostly we bring the human being into deciding that the result which we are getting from the cluster are they good result or not. So that is being decided by the human beings, even though there had been few measures has been decided, but still in real world those measures also not work, right? Kumar Dilip is saying awesome session. Thank you, Kumar Dilip, for appreciating. Arun, thank you, Gaurav, for informative session. Thank you for appreciation. Okay, guys, let's finish this session. Thank you very much. Bye bye. Take care. And I also love you guys. You guys are so much great student in terms of asking cool questions, and also I can see how much curious you are, and it always motivate me to teach me in my best way. Thank you very much, guys. Bye bye. Take care. Good night.